do here is that now I'm just going to wrap up the whole thing. So what am I doing? The cart is now going to start oscillating about the equilibrium point. So this means here, I'm going to bring up a whole new case, which I didn't talk about before. But now what we want to do here is that now we have a cart oscillating about the equilibrium. Now, I think the best thing that we should do here is that redraw our thing here. So if I redraw our potential well, what does it look like? Well, let's see if I can do this here. Let's say 1, 2, 3, 4. 1, 2, 3, 4. So let's see if I can draw a good curve. That looks good enough. So if you're looking at this guy here, remember, in the energy world, this is something that you can't escape. You can't go through this energy field right here, right? You can't go through that spring energy field. So what's happening to the cart? Well, what we know here is that we have a cart, right? Here's my cart. And when I'm looking at this cart here, what we know here is that this cart is then, we know it's at the turning point, and what's it going to do? Well, as it goes here, we know that there's a displacement in this direction, and we know that there's a spring force in that direction. So what's going to happen? The cart's going to come, and it's going to reach what? The equilibrium point. And so now we've already talked about how it goes up, and then it comes back down. But then this tells us here that if nothing is lost, this turning point right here, right? This is X turn. And then this turn right here is going to be X turn. Then what's going to happen here is that the cart is going to reach its maximum height right here. And as it reaches its maximum height, what we're seeing here is that as it's going up, what's happening? As it's going up, we know that there's a displacement along that direction and a spring force in that direction. So what's it going to do? It's going to stop it at the turning point eventually. And then what's the cart going to do? It's going to start coming down. And as it starts coming down, I have the spring force, and that spring force is going to do work until it maximizes the kinetic energy at the equilibrium point. So this guy is really what? This is turning point number 1, and this is turning point number 2. And it's going to oscillate back and forth. So now, what does this look like in the work versus position diagram? So question, what does this look like in a force versus displacement curve? Well, what we do know here is that if the spring force is negative, when it's in the negative position space, then I get 2 minus signs. So then I should have a positive slope. So that came out really wrong. Maybe I can do a do-over and scratch what I just said. Okay. What I really mean is that the force is positive. The slope is still negative, but the force is positive. But now I have X in the negative direction. So the first thing I'm going to do here is I'm going to set up a curve. So here I go. Here's my curve. And probably the first thing I'm going to do here is that I'm going to try to draw somewhat of a symmetric curve here before I start to change anything. So if I look at this thing, let me try to be nice and clean. We have something like this. Remember, this is the spring force, which is minus kx. And what we want to do here is that, of course, we need our horizontal axis. And if I look at this horizontal axis, it's going to look something like this. Whoa, maybe not so much like that. How about like this? And so what you're seeing here, I have two curves. Well, I have my first turning point, right? Here's my first turning point right here. So this represents the so-called green area that we were talking about beforehand. So this is on the right side of the potential well. Now to separate the two, I'm going to say that if this is 1, 2, 3, 4, 5, 6, this should be 1, 2, 3, 4, 5, 6. So this would be the other turning point right here. So this is X turning point number 2. This is X turning point number 1. And of course, that's the direction of X. And so what you're seeing here is that then this guy here, when I'm looking at this thing, it should be somewhere around here. So this guy, I'm going to sport it in a blue curve. I'm filling blue here. So then check this out. We know that in this case, that there are two possible situations. So if I move away from the equilibrium, okay, if I move away from the equilibrium, then that means I have my spring force and my displacement in opposite directions. So now I have a spring force that's negative. So it's going to reduce the kinetic energy of the cart. However, if I now coming back towards the equilibrium, where these guys are in the same direction, then the work of the spring, as we already talked about, is positive because I move from a more negative to a less negative number, which requires positive work. So then here I go again. I'm going to do the exact same thing. So then what happens is that then it's the reverse. As I start to move away from the equilibrium, then what I'm having here is that I'm having my, let me be more careful. I'm going to have my spring force and my displacement in the opposite direction. So in this case, the spring force is negative right there. And it's going to slow the kinetic energy of the cart. On the other hand, if I'm coming back, this guy's feeling the force. And so therefore, that work is positive. So so I said that in pictures here. And so then I could then come back and say it in words just to summarize then, right? So in summary, to make sure that you're following me, here's the first thing that I would say here. So when the displacement points towards the equilibrium, right? Right? There's two situations for this. If it points, that means here that I'm either going like this. Oops. The first case was that I was doing what? I had the spring force and the displacement like this, or I have it like this. So in each of those situations, when they point towards the equilibrium, then the work of the spring is positive. And if it's positive, then the work energy tells us that I'm going to have a positive change in kinetic energy, and therefore there's an increase in speed. No surprise. And then it's the opposite now. When the displacement points away from the equilibrium, then I have the opposite case. So when I look at the red cases here, what this tells me here is that in one case, I have the spring, I'm going away, or you could see that it could be the opposite. I'm going away from the equilibrium, and the spring force doing that. Then what that tells us here is that the work of the spring is negative, which means then that the kinetic energy must be negative. And if its kinetic energy is negative, then that means there must be a decrease in speed, right? And I think that graph, if you know how to read it, you can see here how I get the shape that we're talking about. So what we're really plotting here in this energy graph, right? So if I was to take this energy graph and then look at this thing, and then here's my last summary here. So why does the energy graph look the way it does? So let's plot this thing here. So if you're looking at this thing, look what I'm really plotting here. Okay, let's take some of the stuff out, so we don't want to look at that. Okay, and what you're seeing here is that this plot of the car is really what? What it is here is, check this out. If this is position, this is the energy of the spring. And what's the energy of the spring? 1/2 kx squared. You get that parabola. Okay? You get that parabola. And so what you're seeing here is that this is the energy viewpoint. Not the springs. There is no springs. The cart doesn't really look at the springs. It looks at this energy well that it has to move in with. So